a foreign key is a key that is used to link data in two relations, between two relations. So you have a set of attributes in the first referencing relation, or just one attribute. The set could just have one attribute in it. And that can be a foreign key if its value either matches a candidate key in the second relation, sometimes called the reference relation, or it is null. This is used to enforce referential integrity, and sometimes it's even called referential integrity. But basically, what foreign keys let you do is link data between two relations or tables if you're being a little bit more informal about your description. Perhaps things will become clearer with an example. So here we've got some relations. The first relation we have here represents rents in halls and some unnamed West Wales University. The second relation we've got here represents students. Again, same university. So hall is a candidate key in the first of these relations. It's a candidate key because it uniquely identifies the elements, the tuples in that particular relation. There are no repetitions, and there is no subset of hall, which is also a candidate key. In the second relation, we don't need to think about what the candidate key is because we're talking about the foreign key. In the foreign key in the second relation is hall. It's the candidate key of another relation in the database, and every entry in it is either the candidate key in that table relation or it is null. The foreign key can be null for Sue in this relation. It's not a problem. And if you think about the relation and the real-world situation that these two relations are representing, it's perfectly understandable, and we can easily think up a reason why Sue in this case is not in university accommodation. So that makes sense perfectly well. When you update a relation which has got foreign keys in, it might have foreign key dependencies. And if it's got foreign key dependencies, it probably will have foreign key dependencies. You need to think about what's called referential integrity. And that's where integrity comes in here. It's when you're doing updates, you're changing something, you're deleting something, and what happens is that the relations which relied on the table or the relation that you're updating have kind of dangling references. This can cause all sorts of problems. So if we go back to our example, if we take something where there's a foreign key that references it, so in this case Kurt Mauer here, and we want to delete that, there's obviously going to be an issue, and that issue is with Ivor, who is all of a sudden not going to have an entry in the hall thing. It might be that you're bulldozing Kurt Mauer, and that's got major implications for what's going to happen next, but you probably want to have something about your data model that says we don't bulldoze sets of university residents without first checking for students. And that's the kind of real-world implication, and the data integrity constraints will kind of help you model that nicely. If you're going to enforce referential integrity, there are 4 different things you can do. You can either restrict users from doing it, and I think that's probably what you would do if you were going to have the whole deleting a hall option in your database. Someone tries to do something which doesn't fit the data model, something that breaks referential integrity, you stop the user from doing it, you give them an alert, you work out what's going on. The next thing you might want to do is to cascade delete, so anything that referenced the now defunct tuple is now also removed. So in that case, you delete Kurt Mauer, and all of a sudden, all of the students that were associated with that hall, all of the students for whom that hall was a foreign key, would then also be deleted. I think this is probably not the decision you'd want to make in this particular example case, but it might be possible in other cases to be the right decision. You can set the references to null, so the people who were in Kurt Mauer are now in a null hall. That might not be a stupid move. Or you can set them to some default value. As I say before, this probably depends on the application that you're talking about.